friends, welcome to John Newton online class. In this class, let us do this calculation in physics, that is calculation in machines. Remember that in our last class here, we treated machines, the concept of machines, and all the examples and types of machines, mechanical advantage, the terms used in describing machines, velocity ratio, and even efficiency. Now in this class, we are going to look at calculation examples that involves what? Machines. Let's look at the question on the board and tackle it quickly. Okay, the question says a machine has a velocity ratio 4 and is 75% efficient. Now, what effort would be needed to lift a load of 15 kilograms with the head of this machine? So now let us look at the solution. Okay, the machine has velocity ratio of 4, which means the velocity ratio of the machine is 4. Then the efficiency of the machine, efficiency is given as 75%. Then we are not given the mechanical advantage, but we are given the load. The load is 15 kilograms. Now, without wasting time, recall that this load is a force and the unit of force is Newton. So we are bound to convert this load to Newton quickly. And converting this load in kilogram, this mass to Newton, that is the weight of that load, it will now be equal to 15 times 10, which is mass times acceleration due to gravity. And the value of acceleration due to gravity is a constant, is approximately 10 meters per second square. That's where we get this 10, which is equals to 150 Newton. Now, then, first of all, the formula for efficiency, we have that efficiency of a machine in terms of mechanical advantage and velocity ratio, because we have velocity ratio here, is given as MA, that mechanical advantage, over velocity ratio times 100%. Okay, from here now, our efficiency is what? 75. So we have 75 is equal to MA is not given, because we cannot get the effort that you use to lift the load without knowing the mechanical advantage of the what? Machine. So the first thing is for us to determine or to calculate or to find the mechanical advantage of the machine. With that, we can now obtain the what? Effort at ease. Over velocity ratio is given as 4 times 100. Quickly, when you cross multiply this, you will now have 4 times 75 will give us 300. 300 is equal to MA times I have 100 MA. Because MA times 100 is 100 MA. So at this point, we have that our MA will now be 300 divided by the quotient of MA over 100. That is equal to what? 3. So our mechanical advantage is what? 3. But that's not the final answer required of us. We are going to use this as the instrumental laboris, that is an instrument, an agent with which we will now determine the what? The effort so required. Okay, now for the effort, we now find that MA is equal to load over effort. Hope you remember this. We discussed that in our previous class, which is our MA is 3. 3 is equal to our load is 150 Newton now, because we converted the kilogram mass to force in Newton, or to the weight of the load in Newton, equals to 150 all over the effort E. Now, cross multiplying, we shall now have that when we cross multiply this, we have that 3 times our effort is equal to 150, which means our effort is equal to 150 divided by 3. Therefore, our effort is equal to 50 Newton, because it is force, 50 Newton. So the effort required to lift this load using this machine with 75% efficiency and a velocity ratio of 4 is what? 50 Newton. While the mechanical advantage as we obtained in the process is 3. Thank you so much for paying attention to this particular class. I hope you understand the solution method or the process. With this, you can tackle any similar case or any similar problem involving machines or mechanics under mechanical advantage, efficiency, and the velocity ratio. Even work output and work input like we discussed before. For more of these solutions in physics and mathematics, you visit my YouTube channel and there you subscribe, share and like, as well as my Facebook page, all at Geo Newton Online Class. God bless you.